Hello students, we'll do a quick revision of structure of atom and after that we'll start with isotopes. Okay, we have already studied that an atom, it is the smallest particle of an element or matter which take part in a chemical reaction, and atoms, they may or may not exist independently. Okay, so we'll study about the structure of atom mainly here, and then we'll start with the electronic configuration, and isotopes we'll study. Okay, see, atom, if we'll talk about as a whole, an atom, it is neutral. Yes, we know that an atom is neutral. Like suppose I've written Na. This is sodium atom. I'm not putting any charge over it because an atom, if you are talking about, an atom is neutral. Okay, why it is neutral? Now see this. See, the number of protons which are present in the nucleus of an atom, these are positively charged, which are equal to the electrons which are negatively charged, and these electrons are present in different energy shells or energy levels of an atom. So if positively charged protons, they are equal to the negatively charged electrons in an atom, that's why as a whole an atom is neutral. Okay, now protons and electrons, they are equal in number. Protons are present in nucleus of an atom and electrons, they are present in these energy shells or energy levels. Okay, here electrons are present, and in the nucleus of an atom, two subatomic particles are present. They are protons and neutrons. Protons are positively charged and neutrons, they do not have any charge. That's why the nucleus, it is denoted by this positive charge, because protons, they are positively charged and neutrons, they do not have any charge in them, and collectively these protons and neutrons are called nucleons. Okay, now we'll talk about the electrons which are present in these energy shells and energy levels. What you have to study, they are K, L, M and N. These are the energy shells in which electrons are present. Okay, and electrons, they are present here like this. Here like this, electrons are present in these energy shells or energy levels. Okay, now how to fill all these electrons here? There is a rule to fill the number of electrons in these energy shells or energy levels, and the formula is 2n square. 2n square, it is the formula to fill the electrons in different energy shells or energy level, or to identify the maximum number of electrons which can be filled in these energy shells. Okay, n, it is here, it is a number of shell. Like if you are talking about K shell, it will have n equals to 1. If K shell is having n equals to 1, it means 2 into 1 square, it is equals to 2. It means K shell can have maximum of 2 electrons only, because it is the smallest shell. So it can accommodate maximum 2 electrons. Okay. Now L shell. For L shell, the value of n, see, it is the second shell here. So value of n, it is 2 here. Okay. It means 2 into 2 square. 2 2s are 4 2s are 8. It means this L shell, this second shell, it can have maximum of 8 electrons in it. Now M shell, for M, n it is equals to 3. It means 2 into 3 square. 3 3s are 9 2s are 18. This M shell can have maximum of 18 electrons in it. Okay, maximum of 18 electrons in it. Now the last one is what? N shell. If we are talking about N shell, for N shell, n it is equals to 4. N is equals to 4 means 2 into 4 square. 4 for the 16 2s are 32. It means the number of maximum electrons which can be accommodated in different energy shells or energy levels, they are 2 8, 18 and 32. K, L, M and N. So this is how we can calculate the maximum number of electrons which can be accommodated. Now we'll take 2 or 3 examples to do the electronic configuration. So suppose we'll take here the example of sodium atom. Suppose we are talking about sodium having atomic number 11 and the mass of sodium atom is 23. So if its atomic number is 11, we know that atomic number is equals to number of protons, it is equals to number of electrons. If its atomic number is 11, it means it is having 11 protons and 11 electrons in it. Okay. Now see nucleus. In nucleus, if we talk about 11 protons will be there. Neutrons, number of neutrons still I am not writing, I will write it later on. And now we have to arrange electrons in these energy shells or energy levels. So how we will do that? See, K, L, M shells. We have to put or arrange 11 electrons here. This K shell can have maximum of 2 electrons in it, and L shell can have maximum of 8 electrons. Now 8 plus 2 is 10. How many electrons are left now? 1. So this 1 electron will be filled here in this M shell. Now see, this is the outermost shell. This M is the outermost shell, and outermost shell it is called valence shell. And the number of electrons which are present in this outermost shell, these are called valence electrons. Valence electrons are the electrons which are present in the outermost shell of an atom. Okay, so it is having one valence electron and the valence shell is M. Okay, now we'll arrange these electrons here. This K shell can have 2 electrons. Now L 1, 2, 3, 4, 5, 6, 7 and 8 electrons, and 1 electron will be here. Now we'll see still I have not put the number of neutrons here. If we'll talk about the neutrons, see atomic mass, it is equals to protons plus neutrons. We know that total mass of an atom, it is dependent upon the nucleus only. If an atom is having 100 electrons, then to the mass of electrons will not be calculated while calculating out the mass of an atom. The total mass of an atom, it is dependent upon the nucleus only. And nucleus, it is comprised of protons and neutrons, which are called nucleons. Atomic mass, if atomic mass is 23 and protons are 11, then we will calculate out the number of neutrons. Neutrons will be 23 minus 11, that is equals to 12. It means the number of neutrons which are present over here, they are 12. 12 neutrons are there and 11 electrons are present here, and 11 protons also. So this is how we can do the electronic configuration. If we are knowing the atomic number, it means the number of protons will be the same and number of electrons also will be the same. And electronic configuration is the arrangement of electrons in different energy shells and energy levels. So this is how we'll do the electronic configuration. And if we have to calculate the number of protons, neutrons or atomic mass or atomic number, we have to do, so we will use these formulas only, these two. Atomic mass is equals to protons per neutron, and atomic number, it is equals to proton, it is equals to number of electron. Now see what are isotopes. If you are talking about isotopes, see isotopes, they are the atoms of same element having same atomic number but different mass number. See, they are the atoms of the same element having same atomic number but their masses will be different. Like if you are talking about hydrogen, hydrogen has 3 isotopes having same atomic number but their masses are different, 1, 2 and 3. See, if atomic number is 1 for this also, for this and for this also, if atomic number it is 1, okay, number of proton here, proton is also 1, if proton is also 1, atomic number is also 1, see, mass of this is 1, mass of this hydrogen is 2, and mass of this hydrogen is 3. It means the difference in the atomic mass of an atom, it is because of the difference in number of neutrons. In isotopes, the number of neutrons which are present in the nucleus of an atom, they are different. Isotopes, they have same atomic number but different mass number, and masses of isotopes, they are different because of the difference in the number of neutrons. Okay, study till this definition only, and rest examples we'll do in our next lecture. Thank you.